the partition table. You may optionally create additional partitions, but we'll do that later on when we show you how to create swap partitions and swap files or swap file systems based on files and partitions. So again, we've created a new partition, and by default fdisk defaults to type Linux, type 83 or ID83, which is type Linux. This is the type of file system that we need, or type of partition that we need to create a standard Linux file system such as Riser, ext2 or ext3. However, when creating, let's say, RAID or LVM type partitions, you need to indicate those types of partitions. You can change the type of a partition by indicating option T. When you do so, you can also indicate L to list the different available codes. Here are all of the different types of partitions supported by the Linux kernel. Everything from old-fashioned FAT12 to AIX to Solaris, Amoeba. Virtually every computer and file system partition type that's been invented is supported by Linux. 83, however, represents the standard Linux partition type, whereas there are other types available, such as 82 for Linux swap, which we'll see in the subsequent section when we focus on Linux swap partitions. Linux LVM is type 8E. NTF 86, 87, OS2, Linux Extended 85, and so on. So there are different types available, and you just need to go through this list to select the type. You can print the type, take a look at the type, make changes, but be careful what you set, because it may take effect permanently. So for example, if you were to type 83, it would change the partition type. Now we've exited. Let's return into the partition layout and then print, and you see that the changes are lost. We Control-C just to show you that unless you've written the changes to the partition table, they're lost. So again, we need to redefine the partition indicating new, the fact that it's primary, the first, beginning with the first cylinder, and plus 4096 megabytes or 4 gigabytes. We reprinted its type Linux, and again, to save the changes, Option W to write the table to the disk or to update the partition table. So let's move forward. You may also delete partition if you'd like by using the D option. So this writes to the hard drive, and if all goes well, we'll be able to create a file system on the hard drive. Sometimes there are problems syncing to the disk, especially for disks that are currently in use. So for example, fdisk-L, if we attempted to update the first disk, SDA, by creating a new partition between the cylinders 993 and 1044, sometimes with a running system you'll be unable to do so unless you use the part probe utility. The part probe utility forces changes when you indicate the partition. So note, use part probe followed by the partition, which is usually dev / and the identifier such as SDB1 to force a write to a hard drive's partition table on a running system. This will ensure that you don't have to reboot to commit the changes when using fdisk, as was the case with older versions of Linux. But in this case, we don't have a problem because we saw that the disks were synced, or the disk was synced with no problems. So that tells us that the partition's available, and when we executed fdisk-L, we saw on the second hard drive dev SDB1. So now the partition's available, but this is known as a raw partition. So we should just note that. Note, fdisk creates raw partitions, which works for some applications such as Oracle and perhaps even MySQL, which provides support for accessing raw partitions. In order to make this partition available to the user community, however, we need to overlay it with a file system such as ext2, 3, RiserFS, JFS, XFS, or one of the many supported file systems. Otherwise, the file system will not be available. In other words, in order to make it show up when we use df-h in the list of available file systems, we need to overlay a file system. So step 3 is to overlay or format the raw partition with a file system. And with Red Hat Enterprise Linux, the standard file system is ext2, or optionally ext3, which is a variant of ext2 with simply journaling turned on to increase availability and recoverability of your storage volume. So to do so, we'll use the make2fs command. The make2fs command creates a file system on the hard drive. We also want it to be an ext3 file system. So oddly enough, you still use the make2fs command, not make3fs, but you simply indicate the J option, and that's lowercase j, to indicate that you'd like to turn on journaling, which renders the partition an ext3 file system. So that's going to be dev sdb1, first partition on the second SCSI hard drive, which is really a SATA hard drive, but it appears using the SCSI nomenclature, since SATA is a cross between old-fashioned IDE ATAPI and SCSI in terms of performance, scalability, so on and so forth. So this will overlay the file system and write the inodes. So overlay, format the raw partition with the file system. This will write inodes to partition. Once we've written the inodes, once make2fs has calculated the inodes and has written it to SDB1, the raw partition, the partition then becomes available for mounting, which will be step 4. And then step 5 is to simply ensure that when the system boots, the partition becomes available. So once we've created a file system, we can determine where we'd like to mount it within the Linux file system hierarchy. Once we've made that determination, we'll update etcfs tabs so that when the system's rebooted, the file system is made available to the user community. So with that said, let's go ahead and make 2fs on dev sdb1. There you see the inodes were written to the drive, the journal is being created, and the file system is being properly applied to dev sdb1. This tells us that it's finished, and the file system will be automatically checked every 30 mounts or 180 days, whichever comes first. But you can always use the tune2fs command to check the file system to be sure that it hasn't lost any data or has any orphans or so on and so forth. In other words, ensuring the integrity of your files. With that said, we can now mount the file system. Let's move to step 4. Mount the file system in the Linux hierarchy. This is an easy step. By default, mount will recognize certain types of file systems such as NFS as well as ext2 and ext3. So there's no need to indicate mount type ext3, for example. You can simply indicate mount followed by the raw partition location, dev sdb1, followed by the place within the file system hierarchy that you'd like to have it mounted. Now this depends on what you want the storage to be used for. So you need to take a look at your root and see what's missing or what you'd like to allocate the storage for. We've pretty much got everything available, from opt to etc to var, you name it, it's available. So if we wanted to create, let's say, a new home mount point, home1, that we'll use for a set of our users, that's a good idea. To do so, make directory /home, make it first. Otherwise, home1 that is, otherwise you'll be unable to mount to it. So we're going to mount dev sdb1 to home1, but before we mount, we make directory /home1, and then if it succeeds, we mount. Let's go ahead and try that. We'll echo the exit status. It's 0, which now means if we execute mount, we'll see home1 is mounted and is available. Here it is, dev sdb1, home1, and it's mounted with the default options of read-write, as are the other ext3 file systems. So 2, or step 2 in section 4 is to execute mount. This will reveal, or let's indicate mount or df-h. Either will reveal that dev SDB1 is mounted. If all went well, of course, and as we can see, things did go well. Let's follow that up with df-h. Now we see home 1 is available. It's almost 4 gigabytes, of which 72 megabytes are in use. You might be wondering what's using the space. There's overhead required for every file system, whether NTFS within Windows, ext2 or 3, or RiserFS within Linux. There's always file system overhead to maintain it, such as journaling in this case, space for lost and found, so on and so forth. So there's always a small percentage dedicated to managing the file system, but we have the bulk of the file system available for our usage. So now when we look at LSLTR, using LSLTR home 1, we'll see that there's a lost plus found entry. Let's just copy and paste this and just note that for each distinct file system there's a lost plus found directory. Note, lost plus found is created for each distinct file system, and it stores orphaned items, items that are no longer linked or owned by anyone or that have been discarded. It isn't a recycle bin, so you cannot recover items that you've deleted. That feature isn't in there. However, it will serve as a place to store orphaned items, items that cannot be resolved to users on your system. So now we've got this new file system. We can create items in it. We'll sequence 1 million. Home 1, test.txt. This will create a file of it. And so long as the permissions, if we LSLD home 1, are set accordingly for users, they'll be able to interact with the directory. For example, the home directory has similar permissions, owned by root and root, with permissions 755. But if you wanted to set up a user or modify an existing user with a directory beneath home 1, that's perfectly fine as well. For example, you could use usermod to copy a user's home directory. So if you remember usermod, and we mentioned that these commands always come back, we always use them. We could use usermod to move a user's home directory, providing we're not in it in a directory. Let's just exit one of these to be sure that we're not in it. But you could usermod n student1, but you need to indicate with the D option the new home for the user, which may be home 1 student1, for example, for the user student1. And in this case, the user doesn't exist on this remote system. Let's go ahead and user add and create the user fresh. User add D home 1 student1. The name of the user student1. Since we're on a remote server here, it's part of the confusion when you set up users or interact with Linux systems in a shell environment. You never really know where you are on the system unless you pay attention to the prompt. I am root at Linux CBT Serv 4 as opposed to Linux CBT Serv 1, which is the host system. So